packets. Okay, look at here. If you use this command, you can see many, for example, huge result because we configured hello time as 250 seconds. Okay, let me use this command in R1. In R1, we are sending hello message in R1 in every 5 seconds. Debug is adjacency packets. Look at here. is adjacency related packets. Sending is on for router process. Okay, look at here. After some second, we can stop the debug. Okay, this is the debug. Let me stop the debug with undebug all. Look at here. Here, after I configured or enabled, I enabled the debug. You can see that here we sending serial IIH. IIH means IS hello on serial 10. Three-way state. You know that the three-way state is the adjacency state, as I mentioned before, and the state is up. And also here we received serial IIH, means we receive also hello message from our neighbor on the serial 10. And after that, I will talk about the detail of the, for example, hello message. And in every 5 seconds, we need to send hello. Look at here. This is the first hello we advertised in the 7:53:23. Okay, second. Here, the next hello is sent on the on this time 7:53:28. 5 seconds later, it's okay. And also about the received hello, we received the first hello on the 27. Okay, and this next hello should be received on the 37 or 36. Look at here. This is okay. Okay, this means that we are sending hellos in ISIS independently. For example, R1 can send in 5 second interval, R3 can send in, for example, 10-second interval. It's okay. And also, if you enable the, for example, a debug feature on the R2, you can see many hello message. Let me to show you. Look at here. And don't forget, after enabling the every debug and after using the debug, you should disable the debug. Look at here in R2. I'm using this dangerous command, debug IS, okay? Then adjacency packet. Look at here. Maybe it's result to high CPU usage. You can see that here we have many messages, and it's so dangerous in practical environment. Let me to use undebug all. As you can see, in every 1 second, okay, we have 3 to 4 hello message. Why? Because we configured that you should send hello message in every 250 seconds. Okay, this is the things that you should know about the ISIS adjacency states and also ISIS hello interval and hello multiplier. Now you know that in ISIS we have a three-way states for establishing neighborship. We have the 3 states: down, initialize, and up state, and the up state is the good and last states. And after that, you learn the default value for hello interval and hello multiplier, and also hold time. And finally, you learn how you can configure hello interval, how you can configure hello multiplier, and which is the, for example, commands is a suitable command is good command for verifying these values, will show CLNS interface and show ISIS neighbors. Now, we can continue the conversation about the neighborship, about the hello message with the neighborship conditions. Which parameters should be available in every hello message, okay, should be equal or not equal, for example, to establishing neighborship. You know that in every protocol in every routing protocol that you learned before in other courses, we have neighborship conditions. For example, in OSPF, we have some neighborship conditions. In BGP, we have in EIGRP also, okay? The question is that when you are using the point-to-point links as I used in this scenario, which conditions should be available to a neighborship can be established? You know that when R1 sends R3 one hello, okay, R3 should verify the values inside of the hello parameter, and after R3 understand that the states or that the status of R1 is compatible with itself, they can accept the hello message and they can establish neighborship. In this part, I'm going to talk about these conditions. And this is so important for using the ISIS, and one of the most usage of this part, the neighborship conditions, is for troubleshooting of ISIS. When you have a problem in advertising routes in ISIS, maybe the first things that you should check is the neighborship conditions. Let me to talk about these conditions. The first part of our ISIS neighborship condition is the router type. Let me to talk about the router type and its importance in the neighborship. In this scenario, as you can see, we have 10 routers. I'm going to show you different router types in this scenario. I'm using GNS3. And also, as you can see, we have a table, ISIS adjacency table. It's so easy, and also it's a fun scenario to understanding better the status of ISIS in different router types. First, let me start with the router type of L1. You know that we can configure the router type in level 1 or level 1-2 router, and also level 2 router. The default router type in the ISIS is level 1-2. Cisco uses the level 1-2 router type for easier configuration. When you are configuring router ISIS, then you configure net address. Automatically, the router type now is level 1-2 router. And if you want, you can change the router type to level 1 or level 2 only. In the first part of scenario, I'm going to talk about that when we have two level 1 router that is connected directly to each other, when the router type can, for example, go to the finally establishing neighborship, and when neighborship doesn't establish. When you are using two L1 router and both of these L1 router are members of one area, they need to use the same area ID to establishing neighborship. Look at here, when one of these routers is L1 and the next is L1 also, if you need to establish neighborship between them, because these two routers should exchange LSPs, they need to use the same area ID. I am going to show you. Look at here, this scenario is, for example, empty scenario, and we need to configure it. For example, in R1, I'm using interface serial 10, and the IP address is 10.1.255.255.255.0, and then no shutdown. Okay, this is the R1 configuration, and now we can configure ISIS this in this router ISIS. Okay, you know that the first command is net command, net 49001, then quad 1, and then quad 1. You know that you should use this Unix system ID, and then 00. Look at here, I'm going to configure IS type as level 1. This means that this router now is this IS now is a level 1. For example, IS. Then we need to configure ISIS on the serial 10 of the router 1. All of these interfaces are serial 10. Interface serial 10, IP router ISIS. That's it. This is the first part of configuration. Okay, now we can configure the router 2 also. Conft again, interface serial 10. The IP address of this interface is 10.1.2.255.255.255.0, and no shutdown. Look at here, router ISIS, again the net address. In this scenario, as you can see, I'm using the same area ID 49001 and Unix system ID quad 2, and then quad 2.00. Then IS type is level 1 again, and after that we can configure, if you want, log adjacency change all in all routers in R1 and R2. In R1 also I'm using the same command, the log adjacency change router ISIS, log adjacency change all. Then in router 2, okay, we need to configure ISIS on the serial 10 IP router ISIS. That's it. Let me to check the result. As you can see, now we have adjacency between the router 1 and router 2. Here we have two L1 router. Because we use the same area ID between two L1 routers, now we have adjacency. Let me to show you. Look at here. In the router 1, I'm using show run section router ISIS. Look at here. As you can see, this is the net address. ISIS first, for example, can isolate the last part as the encell, and then it knows that after that we have 6 bytes of system ID, and And finally, the remaining part is system ID. The remaining part is system ID, and system ID is 49001. Let me to check the R2 system ID. Show run again section router ISIS. As you can see here, we have again the same system, the same area ID.